Hi, this is 3.2, 3.3 matrix multiplication. This is for discrete math. Maybe you're watching this for something else and hope you enjoy this. Okay, so what we're going to do is we're going to do 3.2, which is essentially multiplying two matrices that are just row or column matrices, and 3.3 where we would have more dimensions to that. And so it would not just be a column or row matrix. So when we look at this, in order to multiply matrices, the number of columns in the first matrix has to be the same as the number of the rows in the second matrix. The dimension of the resultant will be the number of rows in the first by the number of columns in the second. Let's just show you an example and we'll show you how this works. What is the dimension of the resultant matrix when we multiply a 3 by 4 by a 4 by 8? So this would be your rows, these would be your columns, rows and columns. In order to multiply two matrices, this column number has to be the same as this row number right here, and that we have. So we look at those, we can circle those two. My resulting dimensions then would be getting rid of those, and so that this would just simply be a 3 by 8. That's all you do. As long as the two in the middle match up, you can get rid of the rest. So if I look at this one, can I multiply these two matrices? No, can't multiply. Why? Well, the number of columns in the first matrix does not match up with the number of rows in the second matrix. Now what about this one? 1 by 4 times a 4 by 1. Do they match up? Yes, they do. So what am I left with? Oh, this is a 1 by 1. This is just a single number. That is the resulting dimensions of our matrix. So we're just going to end up with one number here. That's it. This one, for a 3 by 8, you're going to have 3 rows and then 8 going across. So it's going to be 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, and 8 items going over. And we can go dot, dot, dot along here to represent that. But that's how a 3 by 8 would be sorted. This one is just one number right in the middle. Okay, then example for 3.2. 3.2, we just want to multiply a row matrix by a column matrix. And so if I do this, this is how this is going to work. Is that I'm going to take each one of these values individually and I'm going to multiply them respectively by each one of these numbers and then add the result. So what will happen is that whenever I take my first matrix, I'm going to draw a line going across, and then the second matrix, I'm going to draw a line going down. Why? Well, I'm going to take this one and multiply it by 0. Well, I'm sorry, let's do this. My resulting, let's see what my resulting dimensions are. We just did this one. This is a 1 by 4 times a 4 by 1. So I'm going to be left with a 1 by 1. Okay? So 1 by 1. So this is just going to be one number. Well, how do I do that then? So I'm going to take the 1 times 0, and I'm going to add it to 2 times the next one in line, 2 times 1. So everyone as I go across is going to match up with everyone as I go down. And then I'm going to take the next one. Well, you can try this. And then the 4 times the 2. Now that looks like a lot of stuff to get one number. Oh, but it's just addition, so yes, I just need to add this up. So then this would just be 2 minus 3, which is negative 1, plus 8, which would be 7. Now I wrote that wrong because this should be in a matrix form, which is like that. Okay, so that's what we end up with. So that's my example for 3.2. Take the 1, multiply by 0, 2 multiply by 1, 3 multiplied by the negative 1, and 4 multiplied by the 2, add them all up, and that's when we end up with just one number. A lot of nice exercises in 3.2. I encourage you to read that and then go ahead and try those problems. Okay, then for 3.3, I think I'm going to do this into a separate video, so come back to that one and so I can do this example for you.